RCM Blitz is a reliability-centered maintenance methodology designed to develop a complete maintenance strategy for critical assets. The process utilizes an RCM Blitz facilitator or practitioner who works with a cross-functional team to discover failure modes, most of which are unique to the context and environment in which you operate your equipment. In iReliability, the RCM Blitz module is the hub of an integrated approach to designing and implementing a failure modes-driven reliability strategy, returning results in a fraction of the time of traditional RCM methods via a convenient and easy-to-use RCM Blitz wizard. Work orders are generated, ensuring effective communication and tracking, and individuals are assigned specific tasks and durations for participation. Likewise, each resulting task or action that is identified through the RCM Blitz process can be assigned to individuals for execution. This ensures that RCM is not only performed but implemented. Viewed as traditional RCM methodology, RCM Blitz is fully compliant with the SAE RCM standard J1011, while engineered to be quick and extremely effective. As stated in the introduction, conducting an RCM activity in iReliability returns results in a fraction of the time compared to traditional RCM methods because iReliability uses a convenient and easy-to-use integrated RCM Blitz wizard to step you through the process. To access the RCM Blitz module in iReliability, go to the Tools page and click on the RCM Blitz link. When the RCM Blitz wizard opens, you will see several tabs that represent the various steps in conducting an RCM. The first step in the RCM process is to choose what system or asset that you want to conduct an RCM for. Note, an RCM activity can only be conducted at the system or asset level. Simply expand the location hierarchy to the appropriate system or asset. To start an RCM, click on the system or asset and the wizard will advance to the next step in the RCM process. If an RCM already exists against a system or asset, a green dot indicator will be visible against the parent location. Drilling down, you will see a green arrow indicator next to the system and/or asset where the RCM exists. In this demonstration, the palletizer system and the beer conveyor asset have existing RCMs as indicated by the green arrows. iReliability is now your data historian for all RCMs conducted against the systems and assets in your facility. By clicking on the system or asset, you can open and edit an existing RCM at any time. In this demonstration video, we will look at an existing RCM so you can see what a populated RCM looks like. Each step of the RCM process will be explained in detail. Structuring the video in this manner will serve two purposes: A, how to conduct an RCM, and B, how to edit an existing RCM. After we have selected the system or asset, the wizard will advance to the next step in the RCM process. The next step is to define the system functions of the system or asset. The system function describes the reason the company has this asset in place, as well as the performance standards it is expected to maintain. These standards would include things like rate, flow, pressure, quality, etc. As you can see, this existing RCM has several system function descriptions populated. If this were a new RCM, this field would be blank. To add a new system function description, click on the Create Function link. Enter the system function description and click on the Save button. You can add as many system functions as necessary. Any of these existing system function descriptions can be edited by clicking on the function description and then by clicking on the Edit Function link. Edit the system function description as needed and click on the Save button. When you have finished entering all of the necessary system function descriptions, you can proceed to the next step in the RCM wizard. Click on tab number 3, Manage Functional Failures. On the Manage Functional Failures tab, you will list all the functional failures for each of the system functional descriptions you entered on tab number 2. The functional failure defines how the system function can fail at a high level. For example, it cannot produce all the product, or it is unable to maintain a rate, etc. On the Manage Functional Failures tab, you will see a drop-down box. Choose the system function that you want to enter functional failures against. As you can see in this demonstration, several functional failures have been entered against this particular system function description. If we were creating a new RCM, obviously there would be no functional failures entered against any of the system function descriptions. To create a new functional failure, click on the Create Functional Failure link. Enter the functional failure and click on the Save button. You can add as many functional failures as necessary. Again, any of these existing functional failures can be edited at any time. Simply select the functional failure you wish to edit and then click on the Edit Functional Failure link. Edit the functional failure as necessary and then click on the Save button. When you have finished entering or editing all of the necessary functional failures, you can proceed to the next step in the RCM wizard. Click on tab number 4, Manage Component Support Function. Tab number 4 is an intermediate step leading up to tab 5, Manage Failure Modes. Look at it this way. When I choose an asset to conduct an RCM on, that asset will have several asset components. As an example, it will have a motor, pump, gearbox, etc. On tab number 2, Manage System Functions, we defined all of the functions of this asset. On tab number 3, Manage Functional Failures, we defined all of the potential failures for each of those functions. On tab number 4, Manage Component Support Function, we map the functional failures to the components of the asset. On tab number 4, Manage Component Support Function, we select a functional failure and then choose which asset component we want to map it to. Then on tab number 5, Manage Failure Modes, we can define the failure modes. These failure modes will be specific to the component and functional failure that has been mapped to it. In this demonstration, you will see a list of functional failures that have been defined for this asset. We need to map these functional failures as they apply to each of the components of this asset. The process for doing this is easy. Simply click on a functional failure and then click on the asset component you want to map it to. If you want to select more than one component to map the functional failure to, hold down the CTRL, the control key, while you are clicking multiple components. All mapped components in the Select Components list will be highlighted. To unmap a mapped asset component, simply click on the asset component and it will be unmapped and no longer be highlighted. In this video demonstration, you will see a list of functional failures that have been defined for this asset. We need to map these functional failures as they apply to each of the asset components. The process for doing this is easy. Simply click on a functional failure and then click on the asset component you want to map to it. If you want to select more than one component to map the functional failure to, hold down the control key while you are clicking multiple components. All mapped components in the Select Components list will be highlighted. To unmap a mapped asset component, simply click on the asset component and it will be unmapped and no longer be highlighted. Note, you must complete this mapping process for each functional failure as they apply to each of the components of the asset. If you do not complete the mapping process, you will not be able to complete the definition of failure modes in tab number 5, Manage Failure Modes. On tab number 5, Manage Failure Modes, we define the failure modes of the functional failure as they apply to the asset components that were mapped to it. It is important to note that this step of the RCM ensures that the failure modes for each component are aligned under the correct functional failure. For example, if the impeller of a pump becomes worn over time, the performance of the pump will drop off and eventually become evident to the operating crew before the pump completely fails. Therefore, as an example, this failure mode might be written under a functional failure unable to maintain desired flow. When you advance to tab number 5, you will see a drop-down box for the functional failures. This box contains all of the functional failures defined in the RCM. First, select the functional failure you wish to add a failure mode to. In this video demonstration, you can see that there are several failure modes already added to this functional failure. If this were a new RCM, there would be none, of course. To create a new failure mode against a functional failure, click on the functional failure and then click on the Create Failure Mode link. The new failure mode entry form will open. Normally this form would be blank. For this video, we will show a populated form. There are many fields in the failure mode entry form. The first order of business is to choose which component and part that the failure mode will be written against. The drop-down list for the component will include those components that were mapped to the functional failures in tab number 4, Manage Component Support Function. The part list in the drop-down is a database list in iReliability that is specific to the component chosen. As stated, there are many fields in the failure mode entry form. In the following section, we will list each field in a brief description. We will also explain how the information in that field is derived. Keep in mind, much of the information is based on knowledge of the facility systems and facility protocol. Other information is based on your RCM training and knowledge of the failure types. The following is a brief description of each field. Description of the problem. What caused the functional failure to happen? Cause of problem. What caused the component and part to fail? The failure mode is active or passive. An active component provides its duty each time the system operates. Passive components wait for a specific event or condition to occur before they activate. As an example, an e-stop failing in the closed position is passive. The process or system would continue on with the device failed in this state until something else occurred to make the failure evident. Events leading to failure. This statement should describe the things that are occurring to a component or part as it is in the process of failing. Evidence of failure. This is the first sign of evidence by which the operating crew will recognize that functional failure has occurred. This typically is an alarm, but could also be that the machine just stops. Corrective action. These are the events required to bring the process back to normal operating condition. Failure symptom. This is short for the alarm or evidence that all operators will experience when the failure mode occurs. This field will build the RCM Blitz troubleshooting guide. In the failure timing section, these are the following descriptions of the fields. Probability. The criteria for low, medium, and high probability changes for every RCM and is developed by the team prior to the start of each analysis. Consequence. The criteria for low, medium, and high consequence changes for every RCM as well and is developed by the team prior to the start of each analysis. Things that should be included in making consequence decisions are health, safety, and environment, equipment process downtime, product quality, total cost of failure, etc. Curve. The following definitions apply. A equals bathtub curve, typically electromechanical devices such as limit switches, push buttons, relays. B. Classic wear, wear-based components that have been installed using precision maintenance including belts, sheaves, pulleys, chains, and sprockets. C. Steady wear, wear-based components that once installed and put into service, the conditional probability of failure increases over time. Pipes, tires, clutches, and brakes are good examples. D. Best new. These items have a very low conditional probability of failure when first put into service. This quickly increases to a low level of random failures over time. Most hydraulic and pneumatic components fit failure pattern D. E. Random failure modes include human-related errors, as well as ball bearings that have been installed and maintained using precision maintenance techniques. F. Infant mortality, These failure modes include low voltage electrical components and parts as well as human errors that occur at the time of installation, not using precision alignment when installing rotating equipment, for example. Frequency. Based on history or experience, how often do we expect this failure mode to occur? Downtime. Downtime starts as soon as the equipment stops and continues until it is back up and operating at the expected rate. This includes troubleshooting, parts, performing the repair, etc. In the decision flow section, the following are the descriptions of each choice. Evident. Check this box if the functional failure of this item will be recognized by the operating crew during the performance of their normal duties. If a failure mode is not evident, this means the failure is hidden. Hidden failures allow the process to continue with them in failed state. If the failure modes are hidden, the box should not be checked. EHS. Check this box if the failure mode could result in a loss of function or damage that could affect the environment, health, or safety. Operational. Check this box if the failure mode impacts the planned use of the operating equipment in any way. Failure modes that result in loss of equipment, rate, or cost money in any way have operational consequences. This box should not be checked if the EHS box is checked. While the failure mode may in fact result in the equipment shutting down, the task decision will be made in the EHS leg of the decision diagram. When you have finished filling out the failure mode form, click on the Save button at the bottom of the form. You can edit any of the existing failure modes at any time by clicking on a failure mode and then by clicking on the Edit Failure Mode link. Simply edit any fields as necessary and then click on the Save button when you are finished editing. The next step in the RCM process is to define the mitigating actions for the failure modes. A mitigating action is any task performed to reduce the consequence of a failure mode. The process for defining mitigating actions is found on tab 6, Mitigating Actions. On this tab, you will see a drop-down list of failure modes. This list will include all failure modes defined in the RCM. Choose the failure mode that you wish to enter mitigating actions against. To create a mitigating action against a failure mode, click on a failure mode and then click on the Create Mitigating Action link. There are many fields in the mitigating action form. Normally this form would be blank, but for this demonstration we will look at a populated form. We will define each field and describe how the information is derived in the following section. General Information section. Task type. What type of activity is required to mitigate the failure mode? PM, PDM, project, etc. Task description. Clearly describe what needs to be done to ensure that the task is implemented into the CMMS. Who should perform the task by craft and how often it should be performed. While there are fields for this information, it is much easier for the people who are implementing each task if we include this information in the task field description as well. In the part section, part cost. Estimate the cost of the part if information is not available at the time of the analysis. Parts comments. Explain how this part will be managed. Custom ordered, locally acquired, etc. Lead time. The time it would take to acquire this part if one was not available at your site. Stock. You have made the decision to stock this part at your facility. In the assignment information section, craft assigned. This is the resource who will be tasked with completing this mitigating action. Task frequency. How often will this task be performed? Clock hours. If you are rebuilding or replacing equipment, how many clock hours are required on the equipment between rebuild or replacement? Labor hours. How long will it take the craft or resource to complete this task? Outage duration. How long will the asset be required to be out of service while this task is completed? When you have completed the mitigating action form, click on the Save button at the bottom of the form to complete the entry. Existing mitigating actions can be edited at any time. Simply click on the mitigating action you want to edit and then click on the Edit Mitigating Action link. Simply edit any field in the mitigating action as necessary and click on the Save button when you are finished editing. Finally, on the Reporting tab, there are several reports available to you based on the information entered in the RCM. The following are the report descriptions. The EMP report. This report is a summary of the RCM data including all task information. The FAMICA worksheet. The FAMICA worksheet includes all of the data entered in the RCM Blitz database for each component and corresponding failure modes, including probability, consequence, and safety data. Implementation tasks. This task report includes task frequency along with outage, clock, and labor hours. Preventive tasks. This report includes all PM, PDM, operator care tasks along with the task descriptions. Spare parts suggestions. This report will include any spare part decisions made during the RCM analysis. Troubleshooting guide. The troubleshooting guide will list each failure mode that corresponds to a failure symptom.